Clear thinking needs more than one tool. One idea can explain some things well and still fail in other cases. If you try to use one mental model for every problem, you end up forcing reality to fit that model and miss what's really happening. The world has many layers. Some problems follow physical rules. Some involve living systems. Some are about people and incentives. Each area has its own patterns, and a single framework can't cover them all. When many parts interact, no single explanation captures all behavior. One model may show part of the truth, but not the whole picture. Thinking improves when you accept this early. You stop looking for one master key and instead build a set of keys, choosing the one that fits the lock. No single model can capture the full picture of reality. A model is a simplified picture of reality. That's why it's useful. It reduces complexity, helps you focus, and allows you to make predictions. But every simplification leaves something out. A model is not the thing itself. It's a way to describe the thing. It highlights certain features and ignores others. That's why a model can work well in one situation and fail in another. For example, you might ignore air resistance to understand basic motion first. That's helpful at the start. But if you care about how a real object moves through air, you have to add that factor back in. The first model wasn't wrong. It was limited. Thinking becomes clearer when you treat every model as partial. You ask what it includes and what it ignores, and you don't mistake a clean map for the full territory. All models leave out part of reality. Overusing a good model can turn it into a problem. Once a model works a few times, it can become a habit. You start using it everywhere. That feels efficient, but it creates blind spots. You stop seeing facts that don't fit the model. Attachment to one explanation is not the same as understanding. If you love a model too much, you start protecting it and rejecting other views without checking them. The mind prefers familiar tools and resists switching, even when a new approach would work better. You can spot this when you keep using the same explanation for different problems and stop asking what's different in each case. You may keep applying the same solution even when results are poor. Clear thinking requires switching models when the facts demand it. Overuse of one model reduces understanding. Different problems have different structures. Not all problems respond to the same approach. Some are mechanical. Some are biological. Some are social. Each type has its own key factors. Using the right tool for the job matters. In some areas, you can isolate variables and test clean predictions. In others, systems are messy and depend on history and environment. In human systems, incentives and rules can dominate outcomes. People solve problems better when they can shift viewpoints because one perspective may reveal patterns that another hides. Thinking becomes clearer when you ask what kind of problem you are facing. Is it about measurement, feedback, incentives, or limits of attention? This helps you choose a model that fits. Using the wrong tool can give a wrong answer even if you use it well. Matching tools to problems improves understanding. Comparing models shows what each one can and cannot do. A model's value isn't only in what it explains, but also in what it fails to explain. You see those limits more clearly when you compare models side by side. Using only one model can make its success look like completeness. Comparing two models reveals gaps, differences in predictions, and different assumptions. You can take one problem and apply two frameworks, then see what each one highlights and what each one ignores. After that, you check which parts match reality. Treating model comparison as a routine keeps you from locking in too early and helps you build a stronger combined view over time. Comparing models exposes their boundaries. Using multiple models also reduces bias. Every model carries hidden assumptions. One may assume people are rational. One may assume old Another may assume people act from habit. One may assume a system is stable. Another may assume it changes over time. When you switch viewpoints, you force yourself to look at the same facts in new ways and notice what you missed before. If you always use the same lens, you'll always have the same blind spots. A second lens can expose them. You don't need hundreds of models, just enough variety to catch your own errors and the discipline to actually use them. Using many models reduces thinking errors. A simple model can be clear and still incomplete. Clarity is not the same as completeness. A model can be easy to teach and apply, yet still miss key interactions. In complex systems, small changes can produce large effects because parts influence one another through feedback. Simple models are good starting points because they build intuition, but you need to know when that simplicity hides important factors. If you ignore interactions, you can predict the wrong outcome. Changing one part of a system can change other parts, which then change the original part again. A single simple rule may not capture this loop. Clear thinking improves when you ask what a simple model leaves out and whether those missing parts matter for the outcome you care about. If they do, you add another model or another layer of detail. Simple explanations can miss deeper complexity. Learning across fields gives you more tools to think with. Many people stay inside one subject area, which limits the models they can use. When a problem falls outside that area, they still try to solve it with the same old approach. Broader learning adds new methods. You can borrow an approach from one field and test it in another. This improves flexibility and makes it easier to reframe problems. It also helps you see when your usual model is failing. You can build this by learning basic principles from different areas, like how experiments work, basic statistics, incentives in economics, feedback in systems, and limits of attention in psychology. Each one adds a tool you can use. Broader knowledge increases model variety. When you feel stuck on a problem, it often means you need a new lens. Repeated failure can signal that you're using the wrong model, solving the wrong problem, or ignoring a key factor. Instead of pushing harder with the same method, you try a different representation, focus on different variables, or test a different assumption. Changing the way you frame a problem can open up new paths and help you escape fixation. You can do this by asking what model you're using right now, then deliberately choosing a different one. If you're using only logic, try measurement. If you're focused on motivation, look at incentives, then compare the results. Shifting perspective reveals new possibilities. No model is final or perfect. Models change as evidence grows. Better data can refine them, and new facts can force revisions. A model may work well within a limited range, and later you learn its boundaries more clearly. Models are working explanations. If they match reality, you use them. If they fail, you change them. History shows that theories improve through correction. Even strong models can be incomplete, yet still useful within their scope. Thinking becomes clearer when you hold models lightly. You don't defend a model as part of your identity. You use it, test it, and replace it when needed. All models are temporary tools, not final answers. Choosing a model is a responsibility. Using a model directs your attention. It shapes what you measure and what you ignore. A poor model choice can lead to poor decisions, even if you're careful. You choose models based on fit. You look at the evidence, consider the scope, and ask what the model can predict and where it breaks. You check its assumptions and whether those assumptions hold in your situation. You also check whether the model can be tested. Thinking improves when you stop using models as slogans and treat them as tools with limits. Choosing the right model improves accuracy. A fuller understanding comes from combining models. Reality is layered. One model can explain one layer, and another model can explain another. When you combine them carefully, your understanding becomes stronger. If one model gives only part of the truth, you look for another that fills the gap. And check both against evidence. Integrated approaches are often better for complex problems because they explain both parts and interactions and allow more reliable predictions. Thinking improves when you stop searching for one perfect lens and instead build a small set of models, learning how to switch between them. Understanding grows when multiple models work together.